Okay, everybody, welcome. It is 4 o'clock, and let's start the presentation. So this week we are going to be talking about logistic regression. Okay, it is a very exciting machine learning algorithm. So let's begin our presentation. So what is logistic regression? What is it? Well, it's when we use the features. Okay, so we got features. These features can be categorical, they can be binary, they can be continuous. And we're going to use these features, okay, to predict the outcome of a binary or multi-class variable. By the way, when we talk about multi-class, what we're talking about is actually categorical, to be honest. Multi-class and categorical, we're talking about the same thing. So we're trying to predict the outcome of a binary or multi-class or categorical variable. Okay, so that's logistic regression. Now, logistic regression, so remember, we got three kinds of machine learning, right? We got supervised learning, unsupervised, and reinforcement learning, right? We got three ones. And logistic regression falls under supervised and classification, okay? Which means that we tell the computer what are the features and what is the dependent variable. We tell the computer, okay? So that's what it means. Now, here's the data set that we're gonna be working on this week. Here's the data set. Here are the variables that we are gonna be working on this week, okay? Out of all these variables, we're going to be selecting features, and we're going to be selecting the dependent variable. The dependent variable here is churn, okay? What churn means is whether the customer leaves your company or stays with your company, okay? If the customer leaves your company, it's a 1. If a customer stays with your company, it's a 0. Okay? That's what it means. That's how you read it. Now, is the dependent variable, okay, or the target variable, is a binary? Is a categorical? Is a multi-class? Yeah, it's definitely binary. So we can definitely use logistic regression, okay? Definitely. Let's continue. Now, let's cover the assumptions. So this model has assumptions, right? The assumptions are the requirements. So what is the assumption? Well, one of the assumptions is that there's a linear relationship between the predictor. And when we talk about predictor, we're talking about the features, right? There's a linear relationship between the features and the log outcomes. What does that mean? Okay, what does that mean? Well, let me explain what that means. So let me give you an example. Okay, assume that this is a survey. Let's say you give a survey and you're trying to predict if the customers are going to recommend your company or not recommend your company. Okay? So 0 means not recommend your company. 1 means they will recommend your company. Okay, so we know that, right? Now, when you give out the survey, you notice something interesting. The customers that rate you between 1 and 5, most of the time, they don't recommend your company. Now, customers that rate you between 6 and 10, most of the time, they did recommend your company, okay? Now, it doesn't mean that every customer that rate you 5 or 4 not recommend your company. And customers that rate you 6 and 7 did recommend your company. That doesn't mean that, but most of the time, that's how it is. So as you can see, there's going to be some type of linear relationship between the predictors, okay, and the log odds. So you're looking for something like this. It's not going to be perfect, but it's going to be like this, okay? The other assumption is that it's a large sample. Remember, for you to build a machine learning model, you have to, okay, you have to have at least minimum 500 observation, and you must avoid extreme outliers. You must do that. Let's move on. What are the major pros and cons? Well, the major pro is that it is a very simple model and it's very easy to interpret. Okay, it's very easy, and that's what you're looking for. You're looking for something that is very easy to make your predictions. Okay? A con, the major con, is that it assumes linearity in the log odds, which is something that I explained here. Another major con is it is very sensitive to multicollinearity. April is wondering, what is multicollinearity? Remember that we want the predictive variables or the features to be independent from each other, meaning that the feature should not be measuring the same thing. They should be measuring different things. Let me give you an example. Education and IQ. These two are measuring the same thing because people with high IQ are going to have a higher education, and people with higher education are going to have high IQ. Is that true all the time? No, but most of the time that's true, meaning that these two are proxy of each other, and you don't want that, okay? If you are building a machine learning model that had education and IQ, you're going to have to decide which feature you're going to keep. Are you going to keep education or are you going to keep IQ? But you're going to keep both, okay? Now, before we continue, let me explain recall precision F1. These are measuring, they evaluate the performance of the logistic regression model. Okay? So it is important for me to explain what they mean. However, before we do that, let me explain how to read the confusion matrix. How do you read a confusion matrix? Well, it is very simple. Here we have the predictive values, okay? These are predictive values. And here are the true values, okay? Here are the true values. So the predictive value, here's how you read it. So the model, okay? The model predicted 1. That means the customer is going to leave, okay? 1 time. And guess what? The actual was 0, meaning that customer stayed. So there is a discrepancy between the predicted value and the actual value, meaning that this is an error, okay? Now let's continue. So the model says, hey, this is a 1. These customers are going to leave. 6 customers are going to leave. But the actual says, yeah, you're right. Those customers did leave. So that's actually correct. Correct. Let's continue. The model said these customers are going to stay, 24 of them. And the actual said, yeah, you're right. Those 24 did stay. Correct. Correct. The model says, well, these customers are going to stay, 9 of them. But the actual says, no, those customers left. So error, okay? So as you can see, the errors are here and they're here. The correct ones are here, okay? The correct ones are here. And that's how you read a confusion matrix model. A confusion matrix, actually. Now, let me explain precision and recall. And when you look at this precision and recall, you probably, if you were to read this definition, you're going to assume that they're talking about the same thing, but they're not talking about the same thing, actually. They're talking about different things. Let me explain. You want to use the recall score when you are trying to avoid false negatives. What does that mean? It means the following. Let me give you an example. Let's assume, okay, that you are trying to create a machine learning model that predicts whether a patient has cancer, yes or no. Now, you are trying to avoid false negatives, right? Because you don't want to tell that patient, hey, you know something? We're trying to, you don't have cancer, okay? You don't want to tell the patient, hey, you do not have cancer. But in reality, the patient, they do have cancer. That's a major problem, right? Because you're telling the patient, hey, you don't have cancer, but in reality, the patient does have cancer. And that's a problem, right? Because now the patient is not going to get treatment when in reality, a few months later, they die of cancer because they did not get treatment on time because you're false negative. Now, let's continue. Let's focus now on precision. Precision, you're trying to avoid, you focus on precision, we're trying to avoid false positive. Okay? Meaning that, let me give you an example so that you understand this. Let's continue with the cancer example. Let's say that you're building a machine learning model that predicts if a patient gets cancer, yes or no. Okay. And now your machine learning model said, oh, this patient has cancer. But in reality, that patient does not have cancer. And that's going to be a major problem because now the patient is going to get treatment, is going to get chemotherapy unnecessarily. And this patient is going to, his or her life is going to be a living hell for a few months. And then we're going to realize that the patient does not have cancer, right? So that's going to be a very inconvenient, right? That's going to be very inconvenient. That's going to be really not good at all. So both of them are not good outcomes, right? We don't want false negatives and we don't want false positive, okay? So is there another one? Is there another measurement that can actually take into account false positive and false negative? Yeah, there is one. We'll discuss that later on. Let's summarize. Precision, we're trying to avoid false positive. Recall, we're trying to avoid false negatives, okay? Now, here's the F1 score. Remember, let's continue with our cancer example. So we're trying to avoid false negatives and false positive. We don't want to tell the patient that they don't have cancer when they do have cancer. We don't want to tell the patient that they do have cancer when they don't have cancer. So is there a better score? Yeah, the F1 score. The F1 score takes into account both precision and recall. It's the average of both, okay? Precision and recall. So for our example, the best score will be the F1 score, okay? The F1 score. Here's a summary. Precision, avoid false positive. Recall, avoid false negative. F1 score is a combination of both. Okay? So here's the example we've been discussing. Precision, if we say someone has cancer, how often are we right? Recall, if someone actually has cancer, how often do we detect it? And of course, F1 score, how well are we doing both? And here are application of logistic regression. For example, credit risk assessment. For example, you can use logistic regression to determine whether to give credit to somebody, yes or no. You can use logistic regression to detect if the transaction is fraudulent, yes or no. You can use logistic regression to determine if your customers are going to leave, yes or no. You can use logistic regression to detect cancer, to detect if a patient has COVID, etc. And of course, you can use logistic regression to determine if the email is spam, yes or no. Okay. So now let's take a moment. We're going to review the code, okay? So give me a moment. Okay, so now let's continue and let's focus on the code, okay? Let's look at the code. Give me a second. Let me make sure I'm recording. Let's look at the code. Okay, so let's look at this code. I don't know if you noticed, but if you're gonna look at the codes that I've been giving you, they all seem to be follow a specific pattern. And you're right about that. If you notice that they're following a pattern, you are 100% correct about that, by the way. Okay? In that, for example, let me give you what I mean by that. Look at the first block of code. The first block of code of every single machine learning model, okay, and algorithm is that they import the libraries, okay? The libraries they're going to be using to create a machine learning model. And that's what this one does, okay? We import the libraries. We import them, we install them if necessary. Then the next block of code, what it does, it imports the data set. Okay, whatever data set we're going to be using, that's what it does. It imports the CSV file. And after it imports the CSV file, then we want to see the first 5 rows of the data set. And that's what this line of code does. And we got the first 5 rows, we got the variables, so we can actually inspect how that data set looks like. Okay. Then the next block of code, we want to see some information about these features, all these variables. So we got DS info. And we see that all of them are float, meaning they all have decimal points. That's what it means. And is that true? Yeah, they're all decimal points. Then the next block of code, what it does, we want to look for missing values. Are there missing values? If there are missing values, we want to get rid of those missing values, okay? We want to get rid of those missing values because if you have a missing value, then your machine learning algorithm is just going to completely stop, okay? Completely stop on its track. Then we want to visualize the data set. In this case, we want to visualize the dependent variable. So we got 1, that means we're looking at set 1 means they churn, that means they left the company. And 0, that means they stay with the company. And we notice that there is something interesting here, right? What we find interesting here is that there is there's an imbalance, right? There are more that stay and there are fewer that left. So there's definitely an imbalance here. And because there is an imbalance, then you want to look at either the F1 score or the precision score or the recall score. So which one will you look at? If you think about it, which one will you be looking at? Will you be looking at the recall score, the precision score? Which one will you going to be looking at? Well, here's the situation we're trying to avoid. Okay, we're trying to avoid a machine learning model that tells you that the customer is going to stay, okay? But in reality, the customer left. And here's why. If the model is giving you false positive, okay? It's telling you, oh, the customer is going to stay. Don't worry about the customer. And then the customer leaves. That's a major problem because if you had known that the customer was going to leave, you could have given the customer a discount. You could have given the customer incentive to remain, but now the customer left. Therefore, you want to focus on precision. You want to avoid false positives. Okay? You want to avoid false positives. Okay? So let's continue. Now, let's look at here, histogram. So we got histogram for all the features, right? All the features that we're going to be using. Here, what we're looking for outliers. Okay, we're looking for outliers. And if you look at tenure, everything looks normal. They range from 0 to probably 80. Age, from 28 to probably 80 as well, 90. Income, look at something's up here. You notice that there is something strange, okay? Most of the data fall between 0 and 500, but there is something here. There's at least one data point somehow over here. So that tells me there is at least one outlier. And education between 1 and 5, so everything looks normal. So as you can see, there is something going on with income. There's something strange going on. And maybe we'll find it out. Let's continue. So let me do some erasing here. Okay, perfect. Let's continue. So here's the box plot. With the box plot, we're looking for outliers. This is another one. And guess what? We found it. We found the outlier. Look at income. Remember income, there was something wrong with income? Look. All the income falls between 0 and 500, right? But there is an income here that is like maybe 1600. So that's an outlier. With that outlier, what we want to do is delete it because otherwise it's going to impact the accuracy of your machine learning model. Let's look at everything else. Everything else looks pretty okay, no problem. I don't see any major outliers except for that one. Let's continue, okay? Let's continue. And here, we're trying to see the pairwise relationship between the variables. And let me explain what I mean by that. Okay, here's what we're looking for. Remember, here's what this one tells us. So here the customer stayed. Okay, here the customer left. Do you notice something interesting? The more the tenure, okay, the more the tenure, the more they stay. The fewer the tenure, the more they left. Meaning, when your customer has been around with you for a longer time, they will stay with your company. When your customer has not been around for a long time with you, they will kind of leave, okay? That's what it means, okay? And you can see that in this pattern, okay? Does that pattern make sense? Yeah, it makes perfect sense to me because I know if my customer have been around with my company for a long time, they're less likely to leave. And if my customer have not been around for a long time, they may leave my company, okay? So that's what you're looking for. What else? Look at this one. Age seems to be kind of the same as well. They seem to be seeing kind of similar pattern as well. Income, not that much. Not that much. Churn, education, I don't see too much here, but we'll see what happens, okay? And that's how you rate those graphs. Now, here we have a heat map. Let me explain something about heat map, okay? It shows that correlation between two variables. If there is a strong correlation, for example, 1, a correlation of 1, it is a perfect correlation, okay? That's what it means. If you have a perfect correlation, you get a 1. And look at the color, it's red, right? Every time you get a perfect correlation, you get a red, right? See that? Now, here's red, perfect correlation. And as it goes down, it goes to blue, okay? No correlation. Now, let's look at something interesting. Remember that we want the features to be independent from each other, meaning they're not measuring the same thing. They gotta be measuring different things. And how can you tell if two features are kind of measuring the same thing? The way we tell is that they are correlated. If they are correlated, that means they're measuring the same thing, and we don't want that. And here we see that we have correlation here. Pink. See that pink? Pink. We get a pink correlation here, 0.43. It seems like we have two features that are measuring the same thing here. Interesting. And the two features that are measuring the same thing are tenure and age. Tenure and age. So it seems like it, based on this, that tenure and age are measuring the same thing. And if they are, you may want to consider eliminating one of them. Okay, so let me delete this. Let me delete this. Let's continue going down. Give me a second. Does that data set, is there like something, really, let's see if that actually is true. We will see. So this block of code, what it does, it assigns the features to X. It assigns the target variable to y, or the dependent variable. That's what it does. And then it actually creates, so it takes the original data set and it splits the data set into two data sets, right? So it takes the original data set and it splits it into a training data set and a testing data set, okay? The training data set is going to get 80% of the observation, and the testing data set is going to get about 20% of the observation. Now, what else do we have here? We had that data set was actually scaled, okay? And that makes perfect sense why we need to scale it. Let's look at the data set. Let's go back. If you look at tenure, age, and income and education, you notice that income has high values, right? 136, 80. If you look at tenure, it's actually low values, 11, 33, 7, age, 33, 36, education, 5, 2, 1. So it seems like income really has high values. And if we were to just leave it like this and not do any scaling, then income is going to have a high, it's going to have an undue influence on the machine learning model. And we don't want that, right? We definitely don't want that. So we scale it. So here the data set is scaled the data set. As you can see, the values have changed. They've been scaled. Let's continue. And we train the model, right? We train the model. So here's the model train. We train the model. Now, let's look at the coefficient. Okay? Let's look at the coefficients. Remember that we said that, what did we say? We said that age and tenure are kind of related. Is that true? Well, let's look here and see if that's actually true. So tenure, for every 1 unit of tenure, your churn is going to decrease by 0.75. So it means that as your customer stay with you, for every year that your customers stay with you, the chances of they leaving decrease by 0.75, okay? Now look at the age. As your customer age, the chance of they leaving decreases 0.39. So as you can see, there's definitely a relationship between tenure and age. And let's look at income, and income is the same. As income increases, there is the possibility of your customer leaving decreases by 0.25. The only time that your customer leave is because of the education. The more education they have, the more likely they are to leave your company. So that's very interesting. So it seems like education is one of the reasons why your customer leave. So the more educated they are, the more likely they are to leave your company. That's what it means. Very interesting. Okay. Then we this block of code. What it does, it measures the accuracy. It has an accuracy of 0.72, but we don't want to look at this. We want to look at precision, right? We want to make sure the model actually we focus on precision, because we don't want the model to tell us that, hey, this customer is going to stay, but in reality, the customer left. Okay, give us false positive. This one's going to give us the coefficient metrics, and we already know how to read them in coefficient metrics, right? So here are the predicted values. Here are the actual values. The model predicted the customer will stay 8 times, but in reality, the customer left. Error. The model predicted that the customer will stay 25 times, but in reality, the customer stayed. Good. The model says that customer will leave 4 times, and the customer did leave. Perfect. The model said that customer will leave 3 times, but the customer stayed. Error. Okay. So let's continue. And now we come to the you can say the end. In the end, we deal with classification report. Okay? How do you read this? You read it as follows. So you got two classes. Okay? You got two classes. You got stay, leave, right? And you got observation. You got 20 observation for stay. You got 12 observation for leave. Okay. And then, of course, we have precision, recall, F1 score. So let me tell you, so this is the precision for stay, recall for stay, precision for leave, recall for leave, okay? I'm going to explain what those means, by the way. And then we got the average. Okay? This assumes that both both stay and leave had the same number of observation, equal number of observation, the average. Okay? That's the assumption. And this is the average of precision and recall. However, we know that's not true because we know that there are more stay than there are left. So we have an imbalance. And because we have imbalance, we got the weighted average. Precision weighted average, and recall weighted average, F1 score weighted average. So what do this mean? Oh, here's what this means, okay? So this means the following. When the model predicts no churn, it is correct 76% of the time. And it correctly identifies 89% of the customers who actually stay. That's not bad. And then this means that when the model predicts churn, it is correct 56% of the time. Okay? And you only catch 3% the actual churners, okay? So it is really bad at catching those customers that leave. And that's what we're trying to avoid, right? It's really bad at catching a customer that leave, okay? So customers are leaving and we cannot catch them, we cannot identify them. That's a major problem, okay? That's a major problem. And that's what we're trying to avoid here. So it is not a good model because it's not able to predict or actually identify those customers who are leaving. So it's not good. Bad model. Okay? Bad model. It is not good. Very low scores here. So that's what it means. And that's the end of the lecture. Hope you learned a lot from this lecture. And if you have any question or concern, please send me an email. And wish you a wonderful day. Take care, everybody. Take care.